Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a strong acid, strong base titration example. Again, recap, we're going to be doing finding the moles left in the beaker by doing the difference in the moles of what you've titrated and what you had in the beaker. And then you're going to divide by the new total volume to get the molarity of what's left in the beaker. If it's an acid, you're going to do negative log of H, and that'll be your pH. If it's a base, you're going to do negative log of OH. So if you remember, whatever's left in the beaker is going to be a strong acid or strong base, and a strong whatever we have, if it's an acid, like hydrochloric acid in this case, the concentration of the hydrochloric acid is also the proton concentration, because we have complete dissociation, complete ionization going on here. So, we have a scenario in which we have 0.01 molar potassium hydroxide being titrated into 50 milliliters of 0.01 molar hydrochloric acid. And we basically are going to need to find a calculator as well as find moles of each. So, alright, well, let's see. Okay, so track down my calculator. We have, before the titration, we need to look at this hydrochloric acid, what's in the beaker, and we have 0.01 molar hydrochloric acid, and we have 50 milliliters of it, right? So what we need to remember is that the molarity, again, of the strong acid equals that of the base. I'm going to zoom in a little bit to create some more space since I'm running out. The beauty of the digital world allows me to do that. So here what I'm doing is I have concentration of hydrochloric acid is going to equal to the concentration of your protons, which in this case is going to be 0.01 molar, and then pH is equal to negative log of your protons, so negative log of 0.01, and then if you do that on your calculator, you get 2.0. Yeah, I guess I could have used my algebra if I wanted to, right? This would be log base 10 of 10 to the negative 2. Since both of these are the same thing, the tens, this can come down in front with the negative sign that's there. Give you a 2. Didn't even need your calculator. Look at that. Anyway, so if we're doing during the titration, let's see, how much did I add? 10 milliliters of the titrant. So what we need to know is we need to know how many moles there are in the beaker, take the difference of the moles that you added, and then find the new pH. So let's do just that. Step 1, moles of beaker and titrant. So we have molarity is moles over volume. We have 0.01 molar. We're looking for moles of beaker in this case, and we have 50 milliliters, which is 0.05 liters. So if I multiply, I get 5e to the negative 4 moles, or 0.5 millimoles. Right? Still no need for a calculator, we can do all that. It's 5 with 4 decimal places. Alright, so then that was the beaker. Now let's do the titrant, we have the same molarity, but we have only 10 liters. So this is 1 e to the -4 moles. And we have, that is going to be 0.1 millimole for moles of titrant. So we take the difference, 0.5 minus 0.1 millimoles equals 0.4 millimoles. And this is the moles of HCl left in the beaker. We neutralized the moles that were added in, neutralize the acid, the potassium hydroxide, when we drop it in, neutralize 0.1 moles of the acid, leaving me 0.4 millimoles, sorry, not moles, left in the beaker. Now what we do is we take that molarity or moles, and we create a molarity by dividing by the new total volume. So we had 50 milliliters, or 0.05 liters, and you added 0.01 liters of your titrant. So we have 0.4 divided by 0.06 gives you 6.6. That's not right, because that's in millimoles, right? So that'd be millimolar if I did that, or let's just divide by 1,000. Yeah, times 10 to the -3rd. So then, when you do that, log you get a slight increase in pH of 2. Okay, so when you do negative log of that, you get 2.18 as your new pH. Okay, so you added a little base, the pH went up a little bit, which is kind of what you expect. Again, find the moles of each, take the difference, divide by your new volume, and that's your pH. Okay? Sorry, I got a little distracted by the dogs. Make sure you check out the weak strong interaction. I will also try to get a base in the beaker and acid as the titrant video up as well for strong. But if you understand this one, you should understand the other version. The only difference is that what you'll have left in your beaker will be not the acid. Here it will be the base. So because this is a base, it'll be OH concentration instead of HClH. It's KOH. You have to find the POH and then subtract that from 14. Okay. Also check out the weak strong interaction videos, and make sure you practice. That's the most important part of the equation. And thank you, and have a nice day.